With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In the figure is shown a fixed hollow cylinder with vertical axis. A pendulum is rotating in a conical path with its axis same as that of the cylinder with uniform angular velocity. Radius of cylinder is 30 cm, length of string is 50 cm, and mass of bob is 400 grams. The bob makes contact with the inner frictionless wall of the cylinder while moving. So what they have done is they have given us a cylinder, and along its vertical axis there is a conical pendulum attached, and the inner walls of the cylinder are frictionless. Now, the first option says that the minimum value of angular velocity of the bob so that it does not leave contact is 5 radian per second. So let's draw the free body diagram for the bob. So this is our bob. There is a force m omega square r acting radially outwards. There will be some tension in the string, and if this angle right here is theta, so the components of tension will be and there will be its weight acting downwards, and this will be T cos theta and T sin theta. Now, if this bob is in contact with the walls of the cylinder, this R will be the radius of cylinder. So T sin theta should be equal to m omega square radius of the cylinder, which is 30 centimeters. So 0.3 meters. Let's say this is equation number 1. Now T cos theta will be equal to mg. I'm just balancing the forces. This is equation number 2. Now if I take the ratio of equation 1 and 2, so tan theta should be equal to omega square times 0.3 upon gravitation g. Now what will the value of tan theta? So this length of the string is given to us, which is 50 centimeters, and this radius is 30 centimeters. So tan theta, to find out tan theta, let's find the length of this edge of this triangle. So using Pythagoras theorem, this will become root 50 squared minus 300 squared, which is equal to root 2500 minus 900, which turns out to be 40 centimeters. So this is 40, which means tan theta becomes 3 by 4. So let's put the value of tan theta here. 3 by 4 should be equal to omega square times 0.3 divided by g. So 3 into 10 upon 4 is equal to omega square 3 by 10. 3 and 3 get cancelled. So 100 by 4 is equal to omega square, which means omega is equal to 5 radian per second. So the first option, that the minimum angular velocity of the bob so that it does not leave contact is 5 radian per second, is correct. Now the second option says that tension in the string is 5 Newton for all values of angular velocity. For this, let's take equation number 1 and equation number 2 and square them and add them. So if I square and add equation 1 and 2, what do I get? I get t square sine square theta plus t square cos square theta is equal to m omega square r whole square plus mg whole squared. Now if I take t square common, then sine square theta plus cos square theta will become 1. So t square is equal to, I can take m square common, m square omega square r squared plus g squared. Now that gives me T is equal to M root omega square R whole squared plus G squared. So tension in the string is given by omega square R squared plus G squared. Now as I can see, G is a constant, M is a constant, but omega and R can be varied inside this cylinder. That means the tension is not a constant. Therefore, the option number B that says that the tension in the string is 5 Newton for all values of angular velocity, this statement is incorrect. Third statement says that for angular velocity of 10 radian per second, the bob pushes the cylinder with a force of 9 Newton. So, we have already calculated that for angular velocities beyond 5 radian per second, the bob is in contact with the inner surface of the cylinder. So, if I draw the free body diagram for this cylinder, this is theta, this is tension T. So, tension T cos theta. So, T cos theta should be equal to mg, which means T is equal to mg by cos theta. Now, mg, mass of the bob is same, that is 400 grams, times acceleration due to gravity is same, g. Cos theta, as I said, beyond 5 radian per second, the bob is in contact with the surface of the cylinder. So this geometry is not going to change. So that means cos theta can be found out from this triangle, and cos theta will be equal to 4 by 5. So 4 by 5. That gives us 100. That gives us 5 Newton. So the tension in the string is 5 Newton. Now, if tension in the string is 5 Newton, then the forces acting on this bob along the horizontal are m omega square r and t sine theta. And since we are trying to find the force with which the bob pushes the cylinder, so the force, if the force with which the bob pushes the cylinder is capital F, then capital F will be equal to m omega square r minus t sine theta, which is equal to mass is once again 400 grams, so 0.4 kilograms. Omega is given as 10 radian per second times the radius, since it is in contact with the cylinder, so it will be the radius of cylinder, that is 30 centimeters. So 0.3 meters minus tension 5 newtons, and sine theta will be 3 by 5. So 3 by 5. This gives us 0.4 into 0.3, that is 0.12 into 100 minus 5 into 3 by 5 is 3 newtons, which is equal to 12 minus 3 equal to 9 newtons. So the option number C, that for angular velocity of 10 radian per second, the bob pushes the cylinder with a force of 9 newton is correct. The final option says for angular velocity of 10 radian per second, tension in the string is 20 newtons. This we already calculated. The tension in the string will remain 5 newtons because the vertical component of the tension has only the weight to balance, so its value cannot exceed 5 newtons because the weight is not exceeding this value. Weight is not exceeding this value of mg, and this geometry cannot further be exceeded due to the construction of cylinder around the pendulum. So option number D is incorrect. So the correct answers are A and C.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.